In this video, we're going to learn about square roots and simplifying square roots. This is vitally important for studying any kind of geometry problems, especially those involving triangles, which we'll learn in the second part of this lesson. But in this part, we're just talking about square roots. And when you talk about a square root is a number that is, when squared, is equivalent to a given number. So for instance, if I give you 64 and I ask you what is the square root of 64, I'm asking you what number, when I square it, gives me 64. Well, the answer to that is 8 squared equals 64. Now the way that I denote this is just the understanding. When we talk about the math, we're going to say square root of 64 equals, so this symbol right here means ask you the question, what number times itself equals 64? Well, we know the answer to that because of what I just said, equals 8. So the square root of 64 equals 8. Notice that once I determined what the number is, I no longer needed the square root sign. That goes away. If I don't know what the square root is, then I have to leave the square root sign there. One thing that you find out is most square roots, those that don't have an integer answer, are actually irrational. So we generally leave the square roots because that's an exact answer, whereas irrational numbers are inexact. Okay, one important property of square roots, the multiplication property of square roots, and that says if you've got the square root of x times y, that's equal to the square root of x times the square root of y. So it essentially allows you to separate out a square root. A very specific example to this is something like the square root of 8. Well, the square root of 8 is equal to the square root of 4 times 2, which equals the square root of 4 times the square root of 2. Thus, that we now have a way of separating out the square root of 8 into two separate square roots. This is a positive because I don't know the square root of 2, but I do know the square root of 4. Okay, the square root of 4 is 2, so I can now rewrite this as 2 times the square root of 2. So the square root of 8 is equal to 2 times the square root of 2. Well, that's what we call a simplified square root. A simplified square root happens when a square root has no, and this is a new word for you, perfect squares, which means as a factor. And a perfect square is a number that is a square of some integer. So like 4 is a perfect square because it's equal to 2 squared. You can go through and write all the perfect squareds out. 1 squared is 1, so 1's a perfect square. 2 squared is 4, so 4 is a perfect square. 3 squared is 9, so 9's a perfect squared. Well, it turns out all we really have to worry ourselves with are the prime number perfect squares. And in general, if you know these 4, 9, 25, and 49, you'll be able to solve most of the problems that you have to do. Now, sometimes they don't work, and so you've got to consider bigger perfect squares, like 121, which is 11 squared, or 169, which is 13 squared. But in general, knowing 2 squared, 3 squared, 5 squared, and 7 squared will be able to allow you to simplify all square roots. Okay, so we're going to utilize the multiplication property to simplify these square roots. Okay, so in all these, the directions are to simplify. Now the first one, square root of 64, well, I've already done that as an example, and so you can very easily know that square root of 64 is 8. This is an example where the entire square root is a perfect square. When that's the case, you just write down the integer that is equivalent to that square. Number 2, however, 50 is not a perfect square. No number times itself equals 50, or no integer times itself equals 50. However, there is a perfect square that's a factor of 50. And what you do is you go back to these numbers, 4, 9, 25, and 49, and you ask yourself which one of these goes into 50. Well, 4 doesn't, 9 doesn't, but 25 does. So using the multiplication property of square roots, I now can write square root of 50 as square root of 25 times square root of 2. Now, do not fall into the trap of trying to factor this without using perfect squares. I don't care that this equals square root of 5 times square root of 10. That doesn't help me any, because neither square root of 5 nor square root of 10 are perfect squares. All that matters is that this is a perfect square. And the reason it matters is because the square root of 25 is equal to 5. So that gives you 5 square root of 2. So square root of 50 is equivalent to 5 square root of 2. All right, so let's look at some more examples. Square root of 80, well, again, your numbers that you're concerned about are 4, 9, 16, and 25. Nope, not 16. 40, 25, and 49. Well, if you look at this, 4 goes into square root of 80. 20 times. Now, some of you might be tempted to write the answer as 2, because square root of 4 equals 2 times square root of 20. However, that's not right, because you're not done factoring, because square root of 20 is equivalent to square root of 4 times square root of 5. So sometimes there are more than one perfect square that is a factor of a number. So in this case, square root of 4 is 2, square root of 4 is 2, square root of 5 we don't know, so we just leave it like that. So your answer is 4 square root of 5. Okay, number 4. Again, it looks to me like 4 goes into it. And so that's going to give you square root of 4 times, well, you've got to divide it out. It turns out to be 28. Well, just like the last problem, square root of 4 goes into 28 as well. And so now I've got 7. 7 has no perfect square factors except for 1, which doesn't matter. And so you get 2 times square root of 7, because square root of 4 is 2, square root of 4 is 2. So it just equals 4 square root of 7 is your answer. Okay, 5. Again, start with 4. Well, does 4 go into 180? Well, it turns out it does. Square root of 4 goes into 180 45 times. Now again, you check, are there any perfect squares that go into 45? We know that 4 is a perfect square, so we don't do anything with it, but we also know that 9 is a perfect square, and that goes into 45. So that gives you square root of 4 is 2, square root of 9 is 3, times the square root of 5. Well, 2 times 3 equals 6, so 6 times the square root of 5 is the answer. All right, last one, 392. Again, it's all of these. It turns out square root of 4 goes into all of these. Square root of 4 does go into this. If you can't do it quickly, think about 400. Right? 4 goes into 400 100 times. So it goes into 396 99 times and 392 98 times. Or you can just divide it out. We look at 98. 4 does not go into 98. 9 does not go into 98. 25 does not go into 98. However, 49 does. And I'm left with square root of 2, because 49 times 2 is 98. So square root of 4 is 2. Square root of 49 is 7. You got square root of 2 left over, so your answer is 14 square root of 2. So that tells you how to simplify square roots. You'll have some examples of these problems. We'll be using this a lot in the rest of this week and next week and probably the week after.